So I want to look at this harmonic function challenge, given f of x comma y equals f of x multiplied by f of y divided by f of x plus f of y. We are asked to find f of x. This particular mathematical function looks like resistors in parallel, and you see that it also looks like harmonic mean. And this kind of curiosity made you ask that what kind of function behaves like this? The answer is simpler, and we are going to be proving that. So let's just say solution. The first step is to invert the function by letting another function, let's say g of x equals 1 divided by f of x. So just a way of inverting the function. So I will use g of x because I want to find f of x, and if I'm finding f of y, we will use g of y equals 1 divided by f of y. I hope you understand the logic. Alright, so let me know in the comment section. So now, from here now, if we are going to make f of x the subject of the formula, we will have f of x equals 1 divided by g of x. Alright, so therefore we will have f of x comma y equals 1 divided by g of x comma y. Alright, so let's note this particular expression. So if we recall from the original functional equation, from the right hand side of the equation, we have f of x multiplied by f of y. So now we will write it in terms of g of x. So we have 1 divided by g of x, right, multiplied by 1 divided by g of y, right? So this divided by 1 divided by g of x plus 1 divided by g of y. All right, so here now, since this is multiplication, so we just multiply out the expression so that we have 1 divided by g of x, then multiply by g of y. All right, so everything here divided by, here what we are going to do is find the LCM. The LCM will be g of x multiplied by g of y, right? So g of x and g of x, we have g of y all right, so by that we are going to have y 1 divided by g of x plus g of y. So you have to note this expression as well. Don't forget what we expressed to be here. So we express f of x comma y to be this. However, you have to equate this both star and the one above here. So if we equate them, we are going to have 1 divided by g of x comma y, so equals 1 divided by g of x plus g of y. All right, so if we kind of cross multiply here, what we get is we have g of x comma y equals g of x plus g of y. So let's also note this very well. So yeah, we have this expression. So now at x equals 1, and y equals 1. So we are going to have g of 1 to be equals, this will be g of 1 plus g of 1. Alright, so therefore we have g of 1 equals 2 g of 1. So here now, so we can transfer this to the other side. So we have 2g of 1 minus g of 1 equals 0. And what we'll have is, we'll have g of 1 equals 0. However, let's put our y to be 1 divided by x. And if we do, we are going to have, from the equation above, we will have g of x multiplied by 1 over x equals g of x, right, plus g of 1 divided by x. So now, don't forget, this will cancel out this, and we have g of 1. Our g of 1 is 0 equals g of x plus g of 1 divided by x. Alright, so and here we can transfer this to the other side so that we have g of 1 divided by x equals the inverse minus g of x. Alright, so this is just the inverse. However, let's try to look at another means. So another means will be to consider g of x comma y equals g of x plus g of y. Alright, so if you consider it, we will let our x to be a raised to power n, right? So that means that we have to substitute a raised to power n for x in this general expression I started above. So we are going to have g of a raised to power n equals g of a, right, raised to power n plus, right, so then we have g of y. So however, anytime we have g of x raised to power n, something like this, so we are going to have n then g of x. All right, let's note that. So now another pattern is we have ln xy to be equals, this should be equals to ln x plus ln y, abi. So generally, anytime we have g of x, so we are going to have k ln x, provided our condition of x greater than 0. So therefore, what they ask us to find, so which is our f of x, is therefore equals to 1 divided by g of x, right? So and don't forget our g of x is equals to k ln x, right? So this is our final answer. So we have f of x equals 1 divided by k ln x. This is our final answer. Thank you for watching. So see you in my next video. However, let me try to give you a similar equation so that you can solve at your leisure time. So you can solve this. F of mn equals f of m plus f of n divided by f of m multiplied by f of n. So you can try to solve this, and what you are finding is f of n. F of n is equals to what? So you see this is a bit different from what we saw earlier. So because then we are solving for f of m, and it's just about like changing the numerator and denominator. So see you in my next video. Thank you for watching.